Okay, folks, and moving on to chapter 4. And so my ask of everybody this weekend is to get that textbook. If you don't have it, it's in the bookstore. They're in, okay, and read the chapter. Okay, the chapter 4 is 40 pages. And so if you can't read the whole thing, see how many you can read. You're going to find some of those 40 pages, probably at least 5 to 10 of them are just more demos, like larger code demos. So it's not like your traditional reading. But again, I do believe in learning a little bit from reading the chapter. And so mostly, as you guys know, we're going to spend most of our time in lab. And that's how you're primarily going to learn, but that doesn't mean that we shouldn't try reading and learning from reading. And so this chapter is a little bit deeper dive on working with numbers and string data. Again, we go back to, we've already been working with numbers and strings. But that doesn't mean there's not a lot more to learn. Okay, there are a lot more. There's more that we can do with them that we haven't done yet. And so the first couple of slides in this slide deck reviews something that we've touched on and in a little bit more detail. And so you might remember from last week a very similar chart that I showed you. It had 9 data types on it. And turns out there's more than 9 data types. There's a lot more than 9 data types. But those 9 that I gave you are the most common and most frequently used. Looking at this slide, what data type or data types kind of jump out at you that you haven't seen before? Jack?
Really, it's S byte, U short, and U int.
That's right. And so S byte, U short, and U int. And so the S and the U on the data type represent signed or unsigned. And so remind me, what does it mean if it's an S byte? That means a signed byte. And really, what does that mean? What does it mean for a data type to be signed? It can be negative or positive, right? And what does a U unsigned data type mean? Unsigned means what? It can only be positive. Yeah, exactly. And so that's one takeaway, is that a byte, for example, a byte is only positive. So a byte, the data type byte, is unsigned. Well, it turns out there's another data type. Again, it's not a common data type called signed byte that can go negative or positive. But if you look at the number of values, it's still 255 values. Well, 256 if you include 0, right? So the range is smaller, right? Because it can go positive or negative. Christian?
So why would you not just use signing for the list all the time?
Well, so the question, so the answer to that is 2-part. And so the question is, why wouldn't you just always use signed, right? So it's, well, what are the possible values first off, right? Is it possible for the thing that we're storing data about to go negative? Like I think in our last discussion, we said, okay, the days of the month. Well, days of the month are between 1 and 32. There are no negative days. And so we wouldn't need a signed data type because there's no negative, right? That's the first answer. And the second answer is, at least on paper, you always want to use the most efficient data type. And so you're not wasting RAM storage, right, unnecessarily. So on paper, let's just say in theory, right, in theory, you always want to use the most efficient data type. And so for those 2 reasons, you're going to have to choose between signed data types and unsigned data types and what data type to choose. Again, kind of going up is you go, or I guess you would say go down the chart, you go from 1 byte of storage to 2 bytes of storage to 4 bytes of storage. Of course, the next one continues on with 8 bytes of storage, and then those are all whole numbers. Remember, whole numbers, you could also call those, so it's confusing because int is a data type. And as we've learned, ints only store whole numbers. But as a category, any data type that stores a whole number is referred to as an integral, right? An integral data type, that just means it's a data type that stores a whole number, okay? A byte, an S byte, a short, a U short, an int, a U int, a long, and a U long, those are all integral data types, meaning they all store whole numbers. You would say, and it's confusing on the decimal side because you've got two options. You've got floats and doubles. Those both store decimals, but to refer to those as a category, it's a little confusing because you just call those floating point numbers. Floating point numbers means you can have a decimal point. Okay, so there's categories, integral, kind of sounds like int, and floating point, which just means it can have a decimal. You had a question?
I think you covered it, but like,
Okay.
if you use one of the ones that don't allow decimals, or rather just are only for whole numbers,
Yep.
you can't.
What's your, no, go ahead, finish.
You can't like use any decimals like. In
That's
your,
correct. That's correct. Yeah, if you try and store a decimal in a data type that doesn't work with that, it's going to give you a red squiggly. Okay, let me go ahead and open up a new project here. This is just a dummy project, Council app, and I just want to write a little bit of code. GitHub, spring of 23, and Alexis, you're up at the top, so I'm selecting your account here, and I'll delete this so you won't actually have to deal with this. I'm just going to put this in a lab. My solution name will be CHO4. We'll call this LB1, or we'll just call it class demo. And the reason I wanted to spin this up real quick, and this is just going to be like a little hello world thing, is that each one of these data types in C# have what are called aliases, okay? And, you know, you guys all have aliases. You got your names, and then you got your nicknames, right? Probably every one of us has some sort of nickname at some point in our life, right? That's an alias. And so when I make a variable int my num equals, 32, that is one way to create an int, okay? But when I'm looking at this chart, they also show their aliases. And so under .NET type, you have this other int32 that's essentially, it's an alias for my int. And so I should be able to go into here and say int32 another num equals 12. I've effectively done the same thing. Here. And int32 is an int. Now, you're going to notice something there, the capital letter. And maybe some of you who are paying close attention, you say, why is there a capital letter? And that's actually significant. Because what that capital letter means is that this is an alias, right, for what's referred to as a class. Okay, remember we talked about classes being a what? This is a note card. I said a class is a blank of an object.
Member?
Not a member. Blueprint, right? A class is a blueprint of an object. Okay? And objects have kind of two things that are part of them. What do all objects have? Objects have properties and, Jack, methods. Okay, it's coming back to you slowly. Okay?
Why is it dark green like that though?
Because that indicates that this is what's called a reference type, aka a class. Okay, that's what that means, that this is a class. Okay, so let's kind of tie this together. I said, hey, this variable called another num is essentially int32 is a class, another num is our object, and objects have methods and attributes, or we would call them properties. Okay, so this is actually significant. What this allows me to do, if I do console.writeLine and I do my num dot, look at all these things that come along with the variable my num. We could say my num2 string, and that's probably the most common thing that we're going to do. But what are these? I type in my num dot and I get, these are actually methods. Now, this is important because not all languages are this way. Okay, some languages, Java comes to mind, if you have an int, the only thing that int can do is store a number. It has no methods that come along with it. Okay? But because of the way C# is built, all of our data types like ints, they have these aliases, right? And what that means is these data types are objects. These are objects, and with our objects we get methods, and therefore we can do some things. We can do some things with our ints. We can do some things with our doubles. We can do some things with our floats. And that's significant because not all languages are that way, but in C# it is. Okay, so this is actually kind of nice because, well, sometimes we need to take a number and convert it into a string. And we can do that. And now that's really not showing a whole lot. My number is 32. It spits out 32, and that's really not dependent on that. It would work regardless. Okay. But that's more or less what you're seeing on that slide when it says the .NET type. That's an alias for a class. And one more thing. This is a shorthand syntax. Actually, when I said, hey, this is int32, another num2, I'll use the identifier, equals new int32. Here's another syntax. Typically when you create an object, if you've ever created an object before, you're going to be familiar with the syntax of line 3. If you've ever created an object before, this new keyword is the identifier that says to create an object. Okay? So literally line 1, line 2, and line 3 are all basically doing the same thing. I just wanted to show you that creating a very simple data type like an int is doing a little bit more. Okay, that's why when we have my num dot, we get these things that are these little blocks. If you can't see it on my screen, they're like these little cubes, right? These little cubes, if you hover over the tooltip down here, it says those are methods, right? If you want to see the operators, and that says, well, so if you only want to show methods, it must not have any properties. These operators, I'm not going to dive into. That's basically what you can do to it, right? You can add, divide, multiply, so on and so forth. Okay, so I think we've covered, all the tidbits on that slide. Here's another one. Here's another one that's new on this third slide right here. Decimal. we have not discussed the decimal data type. And the theory behind the decimal is that if you have monetary values, right? If you're literally working with money, the recommendation is to use the decimal data type. It offers the most precision of storing significant digits. You can see there are 28 significant digits, which can offer some high precision of your numbers. And so if you're working with money, if you're working with currency, that's where you would introduce the decimal data type. But again, just kind of glancing here, float is 8 bytes, double is 8, and then your decimal is 16. All right. Next slide here, we've covered these bases, I believe, right? How to both declare and initialize a variable. Remind me, what does it mean to initialize a variable?
Give it a name.
No. Let's break it down into two parts. Declaring a variable is giving it a data type and a name. Okay? So the first part of that, declaring, is where we give it a data type and a name. Therefore, when we initialize it, what is that?
Giving it a value.
Giving it a value, but even more specific than that, initializing is giving it a value for the first time. Okay, because you could say that when you're giving a variable a value, you're assigning it. That's done with the assignment operator. The assignment operator is the equal sign. Okay, but when you give it a value the first time is your variable initialization. You're giving it a value for the first time. Okay, we know that variables are stored in RAM, and we know that they take up varying amounts of space for the most part. Not much space. We've used camel notation for our variable identifiers. Okay, there's another notation, and I think the book covers it eventually. How does camel notation work? The first word is what? Is all lowercase, right? So first name is lowercase FIRST, capital NAME. Okay, this is camel casing, which is a coding convention, okay, a coding practice. Again, there's syntax rules, which are hard rules, legal or illegal, and then there's conventions, which are basically how your company does things, okay, or how your school does things. At Rankin and at many companies, our variables are camel cased, okay. There's another convention. It goes like this, like the first word of every word, including the first, is capitalized. All right, this is just called Pascal. Okay, so I mentioned this, I'm going to repeat it. You know, identifiers are things that we get to give names to. Variables are one thing that we get to name. But eventually we will name other things. Besides our variables, we will name our methods. Besides our methods, we will name our classes. We get to name things. Okay? And different things that we name will follow different conventions. Like variables, again, we might use camel casing. You know, our classes, our methods, these kinds of things, it might follow Pascal casing. Okay, just realize these are your conventions. Okay, and they say try to use meaningful names that are easy to remember. Again, I just want to emphasize you want to be thoughtful here. A bad variable name is like integer x, because I know that's what's used in your math class, but no one really knows what x represents. It should be a good, meaningful name. And of course, easy to remember. Sure, why not? Okay, looking at this slide, we're just declaring a bunch of variables. Here they're declaring an int, a long, and a float. Look at the float for me. And you guys have kind of been exposed to this. What does that letter F do for us?
It shows that it's a float, not a double.
It converts it to a float. Because why do we have to convert that to a float? Scott?
For the compiler to be able to interpret it properly.
Yeah, that's right. The compiler looks at this number and it sees a double. It's like, hey, I got to pick a float or a double, and the compiler picks a double. Okay? And instead, I don't want it to be a double, I want it to be a float. Now, here's my next question, and this is going to be relevant in the future, okay? My question is this: which one has more storage capacity, a float or a double?
Double.
Okay, a double. Okay? So when you're going from a data type that has more storage to a data type that has less storage. Everyone with me? We're going from a double, we're getting it down into a float. Okay, when you do that conversion, everyone can probably imagine a double with a lot of decimal points, and then you try and convert that to a float that doesn't have the storage capacity for that. What might happen?
It will just,
It could crash. What's that? An error, a runtime error, right? So the point is, you can probably imagine that's not a good thing. It's technically what happens wasn't really the point of my question. The point of my question, you could probably say, hey, I've got these bytes of storage, I've got 8 bytes of storage, I'm going down to 4 bytes of storage. That's probably problematic, okay? That conversion, okay? We're converting from a larger storage unit to a smaller storage unit. Anybody have stuff in storage like a storage outside of their house? You pay a monthly fee. A couple people, right? But you know what I'm talking about. These storage units. What happens when you have a big storage unit and then you downsize it to a smaller storage? You got all this crap and you're trying to fit it into a smaller storage unit. It might not fit. Okay, so that's a problem. That conversion is called a narrowing conversion. Makes sense, right? You're narrowing the precision. Okay? Here's why this is important. Here's why I'm harping on this. Okay? Some conversions in C# happen automatically. Some conversions happen automatically, what you would call implicitly. Okay? An automatic conversion, it was called an implicit conversion. Happens automatically. Some conversions, like this one, don't happen automatically. You have to code them. Right? So there's implicit conversions, which are automatic. There are explicit conversions, means manual. You have to code it. This is what I mean by manual. You have to code it. Implicit conversions that are automatic are basically, you can categorize them, widening conversions. If your data types are being converted to a wider data type, more storage, well, that's easy. It widens the storage. You're going from a small unit to a big unit. Okay? But if you're going from a big unit to a small unit, you have a potential problem. And basically, the people who made C#, they say, if you're going to do a narrowing conversion, we want you to explicitly code that. And again, these are narrowing conversions. In other words, we want you to know what you're doing. We want you to know what you're doing. Because the problem is this. The problem is data loss. If you take a large storage container and cram it into a smaller one, you run the risk of losing data. Maybe some number of numbers fall off at the end. Okay, and so as we go through the class, we'll do some conversions manually because we have to. And typically, on examples like this is exactly that case. We're doing a narrowing conversion, and they just want to make sure that we know what we're doing, that we're putting this into a float data type. And you run the risk of losing data when you're doing narrowing conversions. Take a look at the next one. You're also going to see that decimals are very similar to floats. But if you have a decimal data type, notice the letter at the end is, the letter M for your decimal data type. I think Christian asked the other day, are there other ones, and decimal is one, where you have to do that. This one here, we have population 2 with the underscore. That's considered valid syntax, although we don't typically use that. A lot of beginners, when they store ints, they want to put the commas in there, right? But we don't put commas in there. If you want, for every place there would be a comma, you could put an underscore. That would be considered valid. I've literally never done that. So that's the thing. You could have scientific notation. Again, if you have a number that big and you plug it into your calculator and it gets you to the power of 9 or whatnot, you could do that. Chars versus strings. Remind me, what's the difference when I'm assigning a char versus when I'm assigning a string?
A string is,
No, go.
string is words.
String is words versus a char is
One character.
just one character, right? So when I see double quotes, with someone's name in it, what should that identify to you? A string. So the correlation is double quotes represent strings versus when I'm assigning a char, notice the single quotes. Okay, so if you're just worried about, middle initial, equals, you gotta code that char middle initials equals A in single quotes. Yep.
JavaScript uses the backtick a lot. Are we aware of that?
The backtick. So that backtick we use kind of like the dollar symbol that we're using here. So not in that case, yeah.
So, is single quotes versus double quotes, is that convention or is that a hard rule?
That's a hard rule.
Okay.
Good question. Yeah, that's a hard rule. Absolutely a hard rule. We have a bool data type, which is to say something is either true or false. So it's not Boolean, although going back, there is a class called Boolean, right? So that actually would be valid, right? You could create a variable with the Boolean data type, or the shorthand, just bool. Yeah, totally.
Why do we gotta put an M when we're using decimal?
Aha. You know what? That's a good question, because that is in fact a widening conversion, right? So if you're thinking about that, we're going from a double to a decimal, and that is a widening conversion. Most of the times when you're doing widening conversions, they don't make you do that. But I can tell you leaving that M out won't compile. So sometimes it's just a hard rule, and that's just a hard rule. I don't have any extra reasoning behind it, unfortunately. If I did, there's probably an answer to it, and I just don't know it. Because at the end of the day, someone made this language, and they made that choice. This is going to be a hard rule, and I don't know why they would have done that. You know what I mean? You ever been using a software and you're like, why did the developers do it this way? You know what I mean? And it's like, I'm just not quite sure all the time.
It really bothers you when you know they could have done it a different way.
Yeah. All right. We are almost done here, right? We're winding down. Thank you. It's Friday. You guys are probably ready for the weekend. You know, it's been a long week. Well, 4 days, but it's been a long week. You just took a test. I realize this is not the best timing for a lecture. However, thank you for grinding it out. Thank you for doing your best. All right. We're almost out of here. Just a couple more slides. That'll make Monday a little less painful, right? If we can get further. What do you know about const? C-O-N-S-T. Const. Stands for constant, which means what?
It's the same throughout the whole document
Yeah, it's the same. In other words, you can't change it.
if you don't change it.
You can't change it. If you try to reassign it, you'll get a compiler error. Remember, the compiler tells us when we're making mistakes. Now, here they talk about Pascal notation, which you could use for constants. Okay? More conventionally, I see all caps with underscores. And so that's what we'll use in this class. The one thing to remember about constants that kind of escaped me for a long time was that you must both declare and initialize your constant on the same line. Okay, I thought you could declare a constant and then initialize it later. Turns out you can't. You must declare and initialize a constant on one line of code, and then you can't change it. Okay, and where constants are really useful, where we kind of talked about this already, is making your code what's called self-documenting, right? Instead of having magic numbers just kind of floating throughout your code, you take those numbers, you put them in a constant variable with an identifier, and now your code is more readable to the developer. Okay, so constants can help eliminate those magic numbers, right? A magic number, again, is just like a number that's hanging out in your code that, like if I just see, 0.0075 in some math equation, if I just see 0.0075, what is that? What does that represent? You can store that in a constant, and then instead of using the number in the equation, you use the constant. That makes that equation more readable to a developer. All right? You guys are ready to go. Please, put some effort in this weekend in reading that chapter. Okay? Please put some effort in reading that chapter. We will continue with all of this next week. All right? Have a good weekend. See you on Monday.